Hello students, welcome to this lecture on chemical equilibrium. In this lecture, we are going to discuss a very important thing in the chemical equilibrium chapter, that is the thermodynamics of the equilibrium constant. So far we have learned in different videos that characteristics of the equilibrium constant. Then we have learned what are the applications of different of the equilibrium constant. Now in this video we are going to discuss the thermodynamics of the equilibrium constant. So thermodynamics of equilibrium constant. This is K. Mukherjee in Science with Mukherjee Sir YouTube channel. The equilibrium constant do not have any relationship with the rate of the reactions, or we can say it does not have any implications regarding how fast the reaction will be proceeded so that it will go to the equilibrium point. There is no relation against all those things. But equilibrium constant have a very deep relationship with the thermodynamics of the reactions, and that is through the change of the free energy change of the Gibbs, that is we have called the Gibbs free energy change, that is del G. In the thermodynamics chapter we have already studied about this, that how del G is very important parameter of a reaction, and that is going to determine whether the reaction is spontaneous or non-spontaneous, right? Suppose if the del G, there is instances, if the del G is negative, means free energy change, Gibbs free energy change is negative, then the reaction is spontaneous. We can simply write it, the reaction is spontaneous, right? This means that reaction, that is the forward reaction, is very much effective in that case, that it will produce much more product than the reactants. That is why we will say when del G is negative, means free energy change, Gibbs free energy change is negative, then the reaction is spontaneous. Another thing, when del G is positive, then we can say reaction is not spontaneous. Reaction is not spontaneous. Means that we can say in different way that its reverse reaction is spontaneous, because when forward reaction, in the forward reaction del G is not positive, this means in the backward reaction, reverse reaction, the del G will be negative, and del G we can see that it will be much more reactive, much more the reaction is much more reactive in the reverse direction. So there will be the much more reactants will be present. There are very few reactant will be converted into the product. So you will say that is reaction is not spontaneous. And third instant you can see when del G is 0. Del G is 0 means reaction in the equilibrium stage. Reaction is in the equilibrium stage. Equilibrium stage. So there is a 3 instances we are seeing that you already studied in your thermodynamics chapter, that when the del G is negative means of a reaction, means the reaction is spontaneous. When del G is positive, the reaction is not spontaneous, and del G is 0, that is reaction is achieved at the equilibrium point. At that point there is no free energy left to carry out the reactions. So that is the 3 things. And there is a mathematical expression of this thermodynamic view of the equilibrium point. That is, the mathematical expression of this is del G is equal to del G 0 plus RT ln Q. What is all the terminology? This del G gives free energy, change, and del G 0 is, this is also gives free energy change, but at a standard condition. With the standard condition, what will be the gives free energy change? This is also gives free energy change at standard condition. That is why this 0 suffix is maintained here. And T is no temperature, R is universal gas constant, and Q is reaction quotient. That we have already studied in the application of the equilibrium constant. Reaction quotient. This is reaction quotient. This is the relationship, thermodynamic view of the equilibrium. And you can see here there is a relationship is this, and it is del G gives free energy change, del G 0 gives free energy change as standard condition, and this is reaction quotient. And now see, this reaction can be further modified. We know when del G is equal to 0. When it is del G 0? At equilibrium point. When the reaction has come to the equilibrium point, then reaction quotient Q is equal to K. Okay, so we can modify this reaction. Del G, this is the reaction with the relationship between equilibrium constant and with the free energy change. As it is 0, we can put this value is 0, then del G 0 is equal to RT ln K. So we can write this ln K is basically minus del G 0 by RT. Okay. Now we take the anti-log of all the two directions, two sides. We will get K is equal to e to the power del G 0 by RT. And you can see this is the relationship between the equilibrium constant with the free energy change. And for this is a very, very important relationship that you can have the assess this relation. You have to remember this relationship, that you can able to predict many things. Like you can predict how the reaction is spontaneous with the help of this equilibrium constant. How? That we will now see. Now this is the relationship we get, as K is equal to e to the power del G0 by RT. And when del G is equal to negative, when the free energy change is negative, then you can see this value e to the power del G0 by RT, this value will be positive. Isn't? Because this is negative and it will become positive, and e to the power this value will be positive. At that time, what will be there? K value is greater than 1. When K value is greater than 1, then what will going to happen? The reaction will goes in the forward direction and the product will predominate. Product, we can write product shall predominate over reactant, right? And when del G is positive, then this factor e to the power RT 0, e to del 0 by RT, this value will be negative. Then K value will be less than 1. At that time we will say that reaction is not spontaneous, so product, reactant, we can say here reactant is predominant over product. So reaction is not continuous over product. So how the K value is correlated with the del G, that we can understand from these discussions. Okay, so that is the thermodynamics of the equilibrium constant, and you can understand from this equilibrium constant also you can able to predict about the spontaneity of the reactions, and that is a very important thing. In the exam, different type of sum in the IIT, JEE and the competitive exam may come. At that time you have to calculate, you have been given this K value, you have to calculate the free energy change of the reaction, or some reactions you can numerically you find, you have to give in the del G, you have to find the K value. Okay, so that is all for today's video. Hope you have enjoyed this video, and that will be a very important relationship in your equilibrium chapter, chemical equilibrium chapter, and many type of numericals may come, right? So that is all to this video, and next video we will discuss the many very important thing, that is the effect of different factors on the equilibrium, and that will be very important, because you have to, if you understand all those things, that it will be very helpful to you. That is all for the viewing, and if you like this video, you can share this to your friends, and thank you very much for watching. Thank you.